Good evening, everyone. My name is Fritz Schroeder, and on behalf of the Lancaster Conservancy, welcome to Nature Hour. Lancaster Conservancy's mission is to provide wild and forested lands and clean waterways for our community forever. We were founded in 1969 by a small group of hunters, anglers, and naturalists who banded together to acquire and protect our critical forests, wetlands, and streams with the belief that some land is so beautiful and rare that it should be protected for public benefit forever. Today, over 7,000 acres and 40 miles of trails are open to you and I to enjoy 365 days per year, thanks to their incredible vision. The urgency that drove our founders continues today as we accelerate our efforts to strategically protect and restore more fragmented forests, to expand and connect our existing preserves, and to create new preserves, all the while building out infrastructure in parking lots, trails, and signage that allow access for the public, while also protecting these incredible ecosystems. Nature Hour is a virtual education and lecture series with the goal of bringing an assortment of local and regional experts directly to your home with presentations that help you better understand both the Conservancy's work and the work of our community and regional partners. Tonight is the conclusion of our winter and spring run of shows. We will return in the fall with a new season. If you want to catch any of our past Nature Hours, you can always tune in to Conservancy TV via Lancaster Conservancy YouTube channel. And we are excited to announce Lancaster Water Week will be returning for its 5th installment this June 4th through 12th. With over 20 partners and events, Water Week is a community festival and awareness campaign that seeks to build momentum around the beautiful streams and rivers of Lancaster County. From virtual lectures on the importance of soil and the history of the Conestoga River to native tree plantings and guided paddles of the Susquehanna River to after-school programming for youth, there are many ways to participate, including the Water Week Clean Water Pledge. Look for event announcements later this week. The Conservancy is blessed with incredible corporate support, and tonight we want to recognize our annual sponsors: Clark Associates, Electron Energy, DART, Ritu Associates, Penstone, and Nimblist. Thank you to these companies for your commitment in supporting Lancaster Conservancy's work and mission. And now it's my pleasure to introduce Keith Williams, who is the Community Engagement Coordinator for the Lancaster Conservancy, one of our very own. He is an outdoor educator, naturalist, writer, and photographer who especially enjoys exploring the often overlooked parts of our natural world. He has a BS in environmental biology from Kutztown University and MS in ecological teaching and learning from the Lesley University Audubon Expedition Institute. Welcome, Keith.
Thanks, Fritz, and thanks everybody for joining us tonight. Let me just share my screen quickly. So it's really important that you all are here tonight so you can learn about how to survive the impending cicada attack. Actually, that's not entirely true. What we're going to talk about tonight is cicadas, and they are some of the most amazing animals on the planet. And in the East, we have the pleasure of being in the presence of periodical cicadas that emerge in mass. And that's got the attention of quite a few naturalists. In fact, David Attenborough thinks this is one of the most amazing natural feats on the planet. But because they do emerge in mass, they're often confused with other organisms on the planet, like these locusts, as in biblical scale locusts, right? These are the things that plagued Pharaoh. These are not cicadas. The cicada is in the front here that somebody superimposed mistakenly on this swarm of locusts in the background. Locusts can do a lot of damage. They're essentially orthopterans, right? Grasshoppers. And they can munch vegetation right down to the ground surface. Just ask Pharaoh what kind of trouble that causes. Cicadas, on the other hand, again, emerge in mass and they congregate in calling centers. They don't swarm like those locusts. And they do relatively minor vegetation damage. That's the result of this. So females will use an ovipositor to lay eggs in about pencil diameter thickness branches. And that causes some browning, what's called flagging, but not nearly the damage that locusts cause. And so locust on the top is a grasshopper, cicada on the bottom is a cicada, two very, very different organisms that are often confused because the cicadas come out in mass. Another misperception is that cicadas have been sleeping for the last 17 years. And that's just not true. They've been very, very much awake in the ground, very much alive for the past 17 years as larval nymphs. And so we'll talk more about this life cycle as we go, but it's absolutely amazing. So they wind up from an egg in the branch after a couple of weeks of development in that branch, and they drop off and they quickly burrow down into the soil. And they live subterranean for 17 years, going through 4 different larval instar molts until they hit that fifth instar, which is the one that emerges at the 17th year. The other thing is that they're not an invader. And this actually bothered me because this came off an entomology site. They're not an invader. They're here. They're part of our ecosystem, and they're here all the time, 17 years in the ground at ridiculously high densities. And while they're in the ground, they're performing really critical functions for that soil. They're aerating the soil, they're bioturbating it, adding nutrients, nitrogen to that soil at really, really high densities. And so we don't fully comprehend the importance of these organisms to soil health, but just given their mass and their volume, it's got to be critical. And so they live underground, and that 17th year happens, and then they come up and emerge. Except this year, we're not 100% sure, with COVID-19, partisan politics, they're really debating whether they want to emerge. And if they emerge, do they need to wear a mask? Not really sure yet. But there's 3,000 species of cicada globally. We have 9 species here in Pennsylvania, and 6 of those 9 species are called annual cicadas. And that's kind of a misnomer because they don't live for just a year. They're actually a 2-year lifespan, and they spend the first year and a half or so underground going through those same larval instars, those 5 different larval instars, and they emerge as the adult, but they don't emerge in mass. They emerge individually. And these are what we call our dog day cicadas. And they're what really define for us a lot of summertime sound, in August and September. But then 3 of the species that we have here in Pennsylvania are called periodical cicadas. And those are the ones that all emerge in mass here every 17 years. And those are all in the Magicicada genus, which I think is one of the most absolutely appropriate scientific names, because these insects really, really are magical. And so 3 different species make up Magicicada, and each of these broods is defined by an accumulation of individuals from those 3 species that all emerge at the same time. So it's not these different species that emerge at the same time. The broods are defined by emergence timing. And you'll see that we've got 12 broods that are 17-year cicadas. We've got 3 broods that are 13-year cicadas. And those 3 broods that are 13-year cicadas are found in the South and in the Mississippi Valley. And so a lot of this evolutionary history of how these periodical cicadas came to be and the periodicity of those emergences, we believe occurred right post glaciation. And every once in a while, we get some errant 17-year cicadas that pop out 4 years early. And in the South, what we think happened is they popped out 4 years early and found really favorable conditions and just so got themselves onto a 13-year cycle. And where we are in Pennsylvania is Brood X. Actually, it's Brood 10, but Brood X sounds a lot more sensational. And this is getting a lot of sensational attention in the news right now. Brood 10 is about to emerge any week now, as soon as soil temperatures hit about 65 degrees. And that's what we have here in yellow in our part of Pennsylvania, Delaware, and then the Midwest, right? Ohio and Indiana. And so a number of questions come up, and we don't have complete answers to a lot of these. And the first one is why periodical? I mean, what's the point of this, right? That they live for 17 years in this larval state underground and then all of a sudden pop out. And how do they know what time it is? How do they know when it's time to emerge? It's not like, all of a sudden they just say, surprise, we're here, right? I mean, we know that they're coming. The question is, how do they know that they're coming? Well, it turns out that as these larval nymphs live in the soil, they feed on root xylem. Okay, so xylem is water and water-soluble minerals that plants take up from the roots. It's a one-way flow from the roots up into the aerial parts. And these larval nymphs, these larval cicadas, live on that xylem on the roots, and they can live deeply, up to 8 feet deep in the soil. So it's not just the surface. Conversely, phloem has more nutritious products in it, right? It's got photosynthetic products like starches and sugars and things like that. They're not eating phloem, they're eating xylem. And that's important because the question of, why are they so long-lived comes up. They're the longest known development of any insect. And we think that's related to a couple different things. And one of those is xylem is not all that nutritious, right? It's really just basically water and water-soluble nutrients. And so it's really hard to bulk up quickly when you're not getting sugars, carbohydrates. The other thing is it's counterproductive for them to kill the plants that they're feeding on. And they have, again, minimal impact on that vegetation at ridiculously high densities. If you remember at the beginning of the show, I think there was a did you know question that cicadas can reach densities of up to 8 million per acre. So imagine 8 million cicada nymphs feeding on roots in a destructive way and what that would do to vegetation. It would decimate the vegetation, what they feed on. And so the 17-year development, we think, is partly in response to what they're eating and partly in response to avoiding predation, because predators have a really hard time timing with that 17-year cycle. And so they count, we think, they count xylem pulses, right? So xylem will pulse in the spring, and these cicadas, we think, somehow count 17 pulses. And after that 17th pulse, they know it's their turn to start digging towards the surface. And again, some of these animals can be really deep, up to 8 feet deep. They start tunneling to the surface. When that soil surface reaches about 65 degrees, that's when they emerge in mass. And the purpose of emerging in mass is to go through one final molt, and that's a molt into adulthood. And the reason that they emerge in mass is it's actually an anti-predation strategy called predator-sation. So even if this bluebird eats its fill of cicadas, it's hardly putting a dent into that overall population. And so there's just so many of them, they essentially completely flood the market of predators. And the predators can eat all they want, and they're still not going to have a negative effect on the population because of these densities, between 74,000 and 8 million per acre, which contribute on average 1 ton of biomass to the ecosystem per acre. So incredibly abundant, incredibly important in terms of nutrition that's being added to the ecosystem. They emerge and they molt, right? So the back of that nymphal exoskeleton splits down the middle. The adult squeezes out. These white hairy things are really, really cool. That's actually the tracheal linings, right? And so these insects have a respiratory system like we do, only it's got some different anatomy and physiology to it. Instead of having a mouth as an airway, they've got some spiracles down the side of their body, and those spiracles lead to trachea, which are also sclerotized, right? That's the hardened exoskeleton. So that also has to shed when that animal sheds out its larval exoskeleton, which is pretty fast. So that's what those white hairy looking things are. Those are actually the insides of the trachea that are shedded. And then they get outside the that larval exoskeleton. They actually pump hemolymph or insect blood into their wings to inflate them. And then they stand out, and it takes them about a day to harden and darken. So you see how this animal comes out white. That's actually going to become a black colored cicada. And this, hopefully it'll play, is a time lapse of that process. Oh, we go back. Anyway, that's the end product. Really cool animal with hardened wings and just, I think, some really beautiful coloration. The purpose as an adult is to find a mate. That's all they do in adulthood, is they emerge from the soil as that last larval instar. They molt into that adult body form. They become a sexually mature adult, and they try to find a mate. And the way they do that is they assemble in calling centers, and the males sing for a mate. So, hey, this is going to be really loud. So if you got an earbud, you might want to take it out for a minute or hold it a little bit away from your ear. But you want to know what the most annoying sound in the world is? That's not an annoying sound. That's a cicada love song, and it works, right? This is the male. The males produce that sound, and this is the male timbal, which is that sound-producing organ. And the thorax and the abdomen actually act as sounding chambers. And so, the decibels that they produce is about 100 decibels, which is the equivalent of a lawnmower. So it's a loud noise. In fact, Ocean City, Maryland is using, they're cicada free, right? So we don't have this emergence that happens on the eastern shore of Maryland. And so Ocean City, Maryland is using this as a marketing tool. Come to Ocean City for peace and quiet during the cicada emergence, if you can consider Ocean City, Maryland, peace and quiet. But anyway, this male has really strong muscles on the ends of those sclerotized ribs, those hardened ribs, and he vibrates them back and forth. And see if this one will play for us here. So you can see those ribs vibrating. to produce that sound. And it works, right? So he's attracted a mate. She says, I think you sing really lovely. And he says, I think you have wonderful eyes. And they go off and they make babies. And they make more babies. And that's really important, right? These are underappreciated animals for our ecosystem based on those densities, again. And they're just fascinating. That whole life cycle is fascinating. And so after the female is mated, she lays her eggs in these pencil diameter twigs, causes that kind of damage and that browning that we call flagging. Those babies will develop over a couple of weeks, which I think they're really cute like that, the little eye spots on them. And then they drop out of the twigs onto the soil surface and look kind of like a white termite. And then they start the process all over again. They go through those 4 larval instars over the course of 17 years, feeding on root xylem, counting those root xylem pulses, which totally blows my mind that these, what we consider to be these mindless organisms can keep track of that 17-year time, and then all emerge in mass when the soil temperature hits 65. And so from our human perspective, this is the life of a cicada: sing, mate, and die, right? And that results in a lot of humor, right? So year 1, stuck in dirt. Year 2, stuck in dirt. Year 3, stuck in dirt. 4, stuck in dirt. All the way up to year 16, stuck in dirt. And then finally, year 17, emergence. And the next 4 weeks, find a mate. Okay, Cupid, Tinder, Match.com, swipe right, swipe left, tap twice. No mate and death. And then finally, someone more romantically desperate than me, right? So from our human perspective, their life is kind of humorous and comical, and it involves simply emerging and finding a mate and dying, and that's it. Forget about the other 17 years that came before this, right? But the sad reality of this is cicadas are part of this, right? You've heard of the windshield effect, I think. Maybe you've heard of the insect apocalypse. The bottom line is we're losing insect biomass and abundance and diversity at a frightening pace. And it's called the windshield effect because, just in a 20-year time span, our windshields aren't nearly as smeared with bug carcasses as they used to be, just 20 years ago. And that's a really scary prospect for us. And that insect loss, and anywhere we look for insect loss, we find it. Insects are largely understudied. And so as we continue to investigate insect populations, we find more and more and more that are either in decline or at risk. And that's part of this larger problem of global biodiversity loss, right? We are at the beginning of a sixth extinction crisis. And, to date, our effort on fixing this problem has been really tiny and has really only involved protecting animals that are cute and cuddly or that they do some kind of service for us. And so, we're losing broods. And so you'll notice that on this list right here on the right, there are brood numbers that are missing. And if you look up in upstate New York, there's this little cluster of these this purple brood, right? 7. That's actually smaller than what that shows right now. And so brood 21 was extirpated from North Florida in the 1800s. Brood 11 has been gone since 1954. Brood 7, the one that I just pointed out, has been reduced to 1 county in upstate New York. And we're watching populations in New Jersey that are being reduced. And, one of the big blockages to protecting these lesser known species that are on the verge of extinction that desperately need protection is population data. And I'm not suggesting that cicadas are in that category. They are not on the verge of extinction. They are far from it. However, when we start seeing those losses, I certainly start to pay attention, right? Dan Ardea, who is a professor at Franklin and Marshall, he's also on our board, said something back in the fall. We were doing this campfire chat for another program, and he said something I thought was really profound. He said the time to conserve something is when it's common. It's not when it becomes rare. And think about the rusty patch bumblebee, right? Just a decade ago, that was one of our most common bumblebees, and now it's critically endangered across the country. And we're not really sure why. We've got a couple ideas. And so insufficient population data is one of the biggest problems that we face when we try to conserve organisms that we don't really know all that well. And so, hopefully at this point in time, you're asking yourself, well, what can be done about this? And there's a lot of things that can be done. And there's a lot of things that can't be done. And one of those things is when I look at this map, I wonder what's up with Maryland, right? It seems like all these cicadas that were reported in the last 17-year eruption stopped at the state line somehow. And so what's up with that? Is that a data collection thing where there were more people in Maryland looking for these organisms than in Pennsylvania? Is it a regulation thing? Is there something in the Maryland regulations about land use or application of chemicals to soil that promote cicadas versus up in Pennsylvania? Or is that just what their distribution is? And so there's something that you can do to contribute to this knowledge. there's a citizen science program called Cicada Safari, and it's an app that you can download onto your phone, and you just log when you're seeing cicadas, and that's really critically important data for us, right? These animals only emerge once every 17 years, and so this is our chance. This year is our chance in the Mid-Atlantic to really try to accurately define the size of this population and to determine if it's changing at all, if it's increasing or decreasing or staying the same, and so that we have that as a baseline for the next 17 years. And the way to do that is with citizen scientists. And so that's an easy action step that everybody can take, is simply go and download Cicada Safari and participate in this data collecting effort as a citizen scientist. The other thing is more about what we cannot do. We've been waging chemical warfare on these organisms for decades. And my fear is that, the silent spring that Rachel Carson talked about she was really talking about birds and losing birds. And that's also happening too, right? We're seeing reductions in birds, which makes sense, right? Birds depend on insects. And so as we see a drop in insect abundance and diversity, we're going to see a drop in bird abundance and diversity. But my fear is that silent spring, we're bringing that on by applying this stuff to our lawns, right? I mean, look at this. This kills 260 plus listed insects by contact, and it's effective for 3 months. And so you apply this to your soil, and it's going to wipe everybody out. And so you're going after the fleas and the ticks. But what you're wiping out, in addition to the fleas and the ticks, are ground nesting bees, right? Most of our pollinators are in significant trouble, and most of those are ground nesters. 28% of the bumblebee species in North America are endangered, and a lot of those bumblers are ground nesters. These crazy looking dragon spawn things produce these amazing illuminated beings. This is a dragonfly, a lightning bug larva. They live in the soil. And so when you're applying this stuff to the soil, guess who you're killing, right? You're killing lightning bugs. Xerces Society, which is this amazing nonprofit that just did the first ever, I believe, study of lightning bugs in North America. We have about 160 species that live in North America or so, found 11% to be endangered, and 50% had insufficient data to make a determination one way or another as to whether they're in trouble or not. And so, don't use chemicals, right? That's something that we can all not do to really make a big impact, not only in cicadas, but also in the health of a whole bunch of other insects that are really critically important for our well-being. And besides us, they're just amazing. I mean, I really, it makes me sad thinking about a summer night without fireflies out. I mean, then think about the densities that we talked about a little bit ago, right? Up to 8 million an acre. Let's take a conservative estimate on this, right? Let's say we only had 1 million cicadas on this typical house building site, which is going to disturb about 1 acre of ground between the house, the footprint of the house, the septic tank, things like that. That's 1 million individuals, right? That's a lot of individuals, and that's a lot of biomass that's lost from this system. And the bottom line is protected land protects them all. And that's what the mission of the Conservancy is. It's to protect as much critically important open space here in South Central Pennsylvania along the beautiful Susquehanna Riverlands and in the Mid-Atlantic Highlands as we possibly can while we can, to protect multiple different species, like all these insects that we just talked about, including the cicadas. And that's important because, a summer without cicadas would just feel really quiet and lonely. And so thanks for being here tonight to learn about this amazing event that's about to happen. And we can take questions.
Thank you so much, Keith. I feel you've taken us on an emotional roller coaster. I'm simultaneously fascinated and laughing and also just devastated by some of those final slides there. Just really incredible. Just to remind people to ask a question of Keith for him to answer, use that Q&A button on your screen. We'll try to get through as many questions as we can here. We got some great time. So let's start it off, Keith. We have someone anonymously here who is asking us, will the Brood X population here result in an increase in cicada killer wasps? Oh,
that is a great question. And I don't think so. That's kind of the one of the beauties of that 17-year timing is that it throws those predators off. And so, maybe next year we might see an increase in the cicada killers because they're going to feast this year. But cicada killers are really tuned into preying on those annual cicadas, those dog day cicadas, which is an amazing thing to watch. If you've ever seen that, it's just an incredible process of watching that hymenopteron, that cicada killer wasp get on the cicada and kill it. And those are also ground nesters, and they're actually really beautiful insects as well. That's a great question, and that's one of those where there's so much that we don't know about these things, and it would make sense that that these predators get a slug of energy, a slug of food this year. You would think that they'd have more energy than to put in increased reproduction for next year. And so you would think that there would be this lag time, like 1 year lag time in cicada killers for next year. That's something we should look at.
Yeah, and just for the people who might not be familiar with what a cicada killer looks like, because I know there's been some news stories out west about people have been confusing as to look like. Maybe we could describe them real quick.
Yeah, so they're kind of for lack of a better word, a bee, right? They're a hymenopteran. So bees and wasps are in a hymenoptera, and they're larger, so they're pretty showy, and they're ominous looking, but they're not going to come after us. And I forget the killer murder hornets, right? I think that was the murder hornet thing. I mean, murder hornets are not cicada killers, right? They're two different things. Murder hornets are not from North America. That's the thing that worries all of us when we get a non-native anything in here, a plant, an animal, a fungus, or an insect, right? Because there's no natural controls on those populations, and they can really do some damage. That's why I'm worried about murder hornets. I'm not worried about murder hornets murdering us. I'm worried about murder hornets as much as I'm worried about lanternflies. And that's a question I have. What effect are lanternflies going to have on the cicadas? Because they might compete for the same space, right? Lanternflies line tree trunks, and those are the tree trunks that cicadas need to go and call for a mate. And so anyway, the cicada killer is a larger hornet-looking kind of hymenopteran. Really impressive looking, just beautiful. I got to see them ground nest. I was camping on the Delaware River this past summer and got to watch a colony of these beautiful cicada killers ground nest together. It was really incredible.
So Keith, we have a question from Becky. She says, you indicate above ground plant damage is minimal. Should we be planting young trees and shrubs this spring, or should we wait till next year? She's not a fan of netting trees. Yeah, that's a great question. And so they can do damage to a young tree to the point of death. And so I believe extension services are recommending that you wait until after the emergence to plant. And so, probably, out of the ideal springtime planting window, but due to heat and dryness. But I think, by the time they mate and lay eggs after that, they're not going to be a threat. And so I think, and I don't know the exact dates that they're recommending. I believe it's mid-June, I think, is what I saw Penn State Extension recommend for planting young trees. That's great information. Kathy has a question that once these cicadas emerge, how many hours per day will we be hearing that love song while they're mating? all day long, all day. And all night too? Into most of the night, yeah. And so that's why, that's one of the reasons why I think, Ocean City ingeniously, I guess, capitalized on that, is come to Ocean City, we're cicada free and quiet, if you can call Ocean City quiet. Yeah, I mean, and rightly so. I mean, actually, the funny story is I was driving back from Colorado at the last emergence. I was doing a project out at Fort Collins on small mammals and was driving a truck and a trailer back. And as I'm driving down 70 through Frederick, Maryland, every time I pass a patch of woods, I think there's something wrong with the truck. And I pull over like 3 or 4 times looking for something wrong with the wheel or what's wrong with the axle. And then I realized it was cicadas in those clumps of trees along Route 70 that were calling. They were that loud. But yeah, it's noisy for sure. But again, it's part of the sound stage of summertime. I mean, I really can't imagine summer without the dog day cicadas calling. And I can't imagine summer without katydids up in the canopy of the forest calling in unison, right? Those male katydids can actually echo and call in unison. And these periodical cicadas do the same thing. And so it's loud, it can be annoying, but it's also, I really soak it in. All right, our next question I did not expect, and it's making me cringe and giggle a little bit here from Julie. She wants to know, how can they be prepared to eat? I don't know if you want to put your chef hat on. That's a great question. And I don't know, I think you can probably roast them, but I know if you go online, you can find recipes for them. And that's actually, when we look at the human population and what we need for protein, it makes sense that we start looking at insects. And there are a lot of cultures on this planet that do that already. There are cultures in Africa that
wait for termite swarms and collect those termite swarms and roast them up. And, you know, they might taste kind of like crab, soft shell crab. I don't know. I might try one. I've had mealworms before. They were kind of tasty. But there are recipes online that you can find. I just don't know what they are. But most of the insect recipes that I know involve roasting.
All right, so we'll get the butter and the Old Bay out.
Right, yeah, there you go.
So we have a question from Liz and James. They're asking when we expect Brood X to emerge this year. I know you briefly touched on this, but just when again should we expect them?
So it's when the soil reaches 65 degrees. So soil temperature needs to be at 65. And I honestly don't know what it is right now. I would imagine that in the first week or two of May, you know, we'll be there and we'll start seeing these. And once they start, it's not like one or two trickle. It's like they are under the surface. Those animals that counted that 17th pulse of xylem are below the surface right now, and they're waiting to go. They are waiting for that soil temperature to reach 65, and then they are up altogether. But it's been a hard spring. Like I've been trying to predict wildflowers at Shanks Ferry, and I've been off on that one because we've had some pretty cool nights that kind of slowed things down. So as of now, I would say first week or two of May. That could accelerate by a couple weeks. It could extend by a couple of weeks.
Thank you for the forecast. How can we tell the annual cicada from the 17-year Brood X cicada?
So Brood X are again 3 species in the genus Cicada, and they're all black. Most of the dog day cicadas are green, and so that's one easy way to tell. Also, the dog day cicadas aren't necessarily emerging at the same time, right? They're typically later in the summer, and they're the ones that we hear calling in August. Each of these animals live for about a month as an adult above ground, including the, you know, again, 9 different species, and so 6 of those are the dog days, and they all have a little bit of a variation in life history. But an easy way to tell is green versus black, as a general rule.
That's a good point. We have a question here. Someone is kind of worried about, or are you worried that, you know, people are going to go out and try to kill cicadas, especially here in Pennsylvania, where residents have kind of recently been taught to kill spotted lanternfly, which, you know, we rightfully know we should kill. But do you think there's going to be this overall move to kill the cicadas as well?
Yeah, I mean, that's always a worry with insects. You know, I mean, you know, people want to kill bees, paper wasps that are really essentially harmless. That also perform a critical function. People don't like those things when they're on their porches, which I get, I understand. And so, yeah, I mean, there was a news story from the Midwest at one of the emergencies last year, or the year before, at one of the Midwest broods of this family that was really proud of their young son who was out there actively killing these things that landed on the house, right? People just don't know. That's the thing. They don't understand these animals that are harmless. They're not going to hurt you. They freak you out. Sure, they're a big bug, right? And they buzz, and they don't have any kind of mouth part that can harm us. And they are called locusts a lot. People really do confuse them with locusts because of their volume, their numbers. And so, you know, they automatically think, oh, it's a plague of locusts, and it's not. You know, a plague of locusts is a real thing that rarely happens in North America, sometimes in the Midwest. Usually that's other continents that have to deal with that tragedy, and certainly not here in the East. And so it's a completely different organism. And so the cicadas kind of get a bad rap. And so I am worried about, you know, people kind of, you know, trying to wipe these things out. And, you know, just like anytime I see folks spraying for mosquito, there's lawn signs on my ride to work now that advertise you can have a mosquito-free yard. Call me and I'll come out and spray it for you. And that's great. I don't like getting bitten by mosquitoes, but that's not a selective insecticide that's being applied, right? That's going to wipe out all those other things that I really enjoy. And so I'm willing to get bit up a little bit by mosquitoes so that I can keep those fireflies glowing.
Agreed. Krista has a question. Do cicadas prefer certain trees or plants to lay their larvae?
That is a great question, and I'm not really sure. My understanding is I think they like maples, but I think they go for the taller stuff. And so I really think they're in such high densities where they occur that it's pretty much anything that's standing is what they're gonna crawl up on. But I would have to investigate that to get a really good answer for you.
Interesting. Elizabeth has a question. She wants to know that on that map that you shared earlier, it looked like Lancaster was right on the edge or the border of Brood X, but not quite in it. She's wondering if we'll see many here.
Yeah, so that's an ongoing question. So historically, we've seen less numbers than other regions, and so again, the question that sticks out on that is that a function of monitoring, or is that just the way the brood here is, right? And so we're really not sure if we're going to see the huge numbers. We know that the Baltimore metro area historically has seen enormous densities. That's the 8 million an acre density area is between Baltimore, Washington, and those surrounding counties. But around here, we're not really sure. And so that's why I'm really interested in folks that are in this region to pick up cicada safari and report what they're seeing, so that we can really get a good handle on this part of the brood. And so on that brood map, Lancaster is in the central part of that, but the densities seem lower here than in other parts where the brood occurs.
Jumping back to the female cicadas and their eggs, we have a question from Ben. He wants to know how the female cicadas actually dig those grooves you showed in the tree branches to lay their eggs.
Yeah, so they have an ovipositor, just like a grasshopper, even though they're two completely different kinds of insects. It's basically this pointy thing that burrows down into the wood, and she deposits her egg that way. Grasshoppers do that in soil, right? So if you catch a grasshopper, it's got that kind of that, and a cricket, right? Those are both orthopterans. They have a pointy, it's not a stinger, but it looks like a really thick twig that comes out of the back of the abdomen of the female, and that she uses that to pierce into the soil and lay an egg. Well, the cicada does the same thing, only in twigs.
We have a really fascinating question here from Joshua. He wants to know about the utility of using a prime number as a hatching cycle. He had read that 17 is used so that they only sync up with their predators, who operate on a 5-year cycle every 85 years for preservation. Is there a difference in the population size on those that operate on that 13-year cycle versus that 17-year cycle?
No, actually, that's why we think it's a 13 and a 17, because they're both prime, and the 4 years off is the key part of that. And so that 13-year cycle also doesn't line up with those 5-year predatory cycles. Yeah, that's amazingly fascinating, right? That's part of the piece that blows my mind, that these insects do that kind of math, or that math happens some way.
It's
right?
just incredible.
But they don't line up because it's a 4-year, right? 13 or 17 4-year difference instead of the 5-year, which would put them more onto the cycle of predatory cycle.
Stacy would like to know that aside from planting any young trees, are there any other kind of agricultural considerations that you might consider or recommend?
I don't think so. Again, you're probably going to see some what's called flagging, right? And that's going to be some browning of some of the peripheral vegetation on some of the trees where the females are laying a large density of eggs. A lot of the papers that I've read on this indicate that that's actually healthy pruning for the above ground vegetation, that it doesn't do any kind of long-term damage. And so we don't really need to worry about it. I know some folks worry about some of their ornamentals that they planted being damaged. And if that's the case, maybe some netting on top of that to keep the cicadas off of it. But I think in terms of a typical forest health perspective, there's not a ton of concern out there that I'm seeing.
Bouncing over back to the cicadas' health, what might the taping and screening efforts that people are using to catch spotted lanternflies right now in our area, what effect might that have on the cicadas?
That's another great question. I don't know. I don't think it's going to have an effect because those aren't cicada eggs. The cicada eggs are buried into the wood, right? They're not planted superficially. And so as people are out there scraping spotted lanternfly eggs, that's a very different looking kind of an egg mass than what the female cicada is going to leave. But that's an ongoing concern that I have. And I am not a fan of a spotted lanternfly by any means, but there are other insects that lay eggs on the exterior surface of the bark of trees. Assassin bugs, for example, which are extremely beneficial for keeping pest insects down, lay a cluster of eggs on the surface of trees. And they don't look like spotted lanternfly eggs, but it's a cluster of eggs that are on the side of a tree. And so, Kelly, are you still there? Did I lose you?
Yes, I am still here. Yes.
Okay, no problem. My screen just changed on me. So I'm worried that those would just be, egg masses and egg masses and egg mass kind of thing. And that those assassin bud egg masses would be scraped accidentally by people that mean well, but are misidentifying those egg masses.
And what about the other forms of traps that people are using right now? Your kind of fly sticky tape with your chicken wire, or some of the more complicated traps? Are those, do the cicadas crawl up the tree to get to their nesting areas? Okay.
And that's definitely a concern, right? So those sticky traps are a concern for a number of reasons. I mean, I've got a number of reports of birds flying into them and dying. But folks might want to take them down this year, because that fifth instar nymph emerges, what it's doing is it's crawling up a tree to find a safe place where it can close or metamorphose into that adult. And the adults fly a little bit, but they do a lot more crawling than flying. And so there's a good chance that some of those spotted lanternfly traps would trap, a pretty good number of periodical cicadas.
And definitely, just a great time to revisit your local Penn State Extension to find out some of those more the better traps to use, it seems like, this spring, if you do go that route. Stacey has a question. She says 8 billion in acre density. Is that between Baltimore and DC? She just kind of wants to figure out, does the density differ? I know that map you showed us earlier showed that everyone, kind of stopped at the state line in Maryland, but that might not be true. What is the density or the expected density?
The density definitely varies, and that's a really large window of density variability, right? Between 74,000 per acre on the low end, up to 8 million per acre on the high end. And so their distribution is going to be spotty based on soil conditions, and we know that they prefer undisturbed soils, and so the expectation is that they would be more preferential to preserved land than developed land, although they seem to do well in suburbia as well. We know that the higher densities are going to be in that DC Baltimore metro area. We know that Brood X is Brood 10 is much more abundant in that part of the world than in Lancaster. So again, I would expect densities in Lancaster to be on the lower end of that scale, and densities in around DC, in the DC metro area counties, to be on the higher end of that scale.
Kind of, again, going back to where they're hatching from, do they seem to congregate in specific areas, like a same physical emergence location? Are there certain hot spots, and then there won't be anything for a number of acres and then another hot spot?
Yeah, maybe not a number of acres, but certainly a patchy distribution within a relatively small area. So they're going to emerge beneath trees because that's what they're looking to do. They want to climb that tree to a close as that adult, and so you'll see clusters of about maybe nickel or maybe even quarter-sized holes, beneath trees. And again, undisturbed soil they really prefer compared to stuff that's been disturbed. And we know that they can't tolerate deforestation. And so anytime there's extensive building going on, they're not going to be there. They've been driven out. Forest fires, poorly timed forest fires, are also responsible for some of the reductions in populations that we're seeing. So if you think about it, if we had a fire come through right as those fifth instar nymphs were just below the surface about to emerge, that would wipe a lot of them out. And so the distribution is going to be patchy, and it's going to be largely based on soil conditions.
That's really interesting. Now, the trees and branches where they lay the eggs, are those branches just dead at this point? You were talking about the browning that happens. Do they recover?
Yeah, both. It depends on the density of the infestation of the young on the ends. And so some of those branches are going to die and be pruned, basically. Others will recover in the next season. But it's really the very tips of those branches, and so they're really looking for those pencil diameter twigs, and not anything a whole lot fatter than that. So smaller branches and twigs that are going to be affected.
So just one final question here. We're just, again, going back to the ecological function of this creature and potentially what's eating it. What are those predators?
Yeah,
I've heard a lot of fly fishermen and women talking about, potentially what would a Brood X cicada fly look like? We talked about birds earlier, but what is eating them?
Everybody. So I know a lot of my fisher friends are really drooling over this, because the bass are going to have a great day. And so it's going to be, if you could mimic a cicada, figure out how to mimic it, the bass are going to go nuts. But yes, let's see, turtles, birds, snakes, possums, raccoons, fox, mice, you name it, they're going to feast on these animals.
We had someone from the comments here say that their dog eats them too. So, and again, I guess we will all be eating them with butter and Old
I tell
Bay.
you, it's worth a try.
Well, thank you so much, Keith. I'm going to welcome back Fritz now for some final words and thoughts here at the end of your presentation. But I just want to say thank you again so much for
everybody.
this very fun presentation. Now, Fritz.
Thank you, Kelly, and thank you, Keith. And thank you everyone who joined us from Lancaster, Elizabethtown, Lidditz, Berks, Philadelphia, Maryland, and Toronto. What a wonderful showing. What is here tonight in Lancaster, a beautiful evening. We just feel very blessed that you join us. I, like many of you, I'm sure, remember finding cicada exoskeletons as a kid. I loved finding them still attached to trees. I loved hearing them on late summer evenings. Is it the most annoying sound, as Keith shared, or a love song? After 17 subterranean years, I think we should give them their moment, their time to sing, their time to shine. Thank you, Keith, for making insect science fun. That was an incredible presentation, for reminding us that we play a key role, we as humans, and impact these and many other insects with how we manage our properties, our lawns, our lands. We look forward to seeing all of you at an upcoming Water Week event or back here later this fall for a new season of Nature Hours. Have a wonderful evening and be well.